Hey, good morning, everybody. This is Mr. Aynesworth at Great Oak High School here in Temecula, California. Good morning. We're going to go into section 5 here in chapter 9 in financial algebra. We're going to be talking about the expense function and the revenue function. And before we do this, let's get set up like we always do in class and get your Desmos up and ready here. All right, we are going to be using the Desmos calculator to our graphing. You could use any calculator you want, but in this class we use Desmos. So let's go ahead and get that set up. Okay, so go ahead and put a number in there and click on save, call it 9-5. Now we're going to be talking about the expense and the revenue functions. So expense and revenue functions. So we're going to be doing all the mathematics behind the economics that you guys are doing in your economics classes. Okay. So after you get your Desmos set up ready, titled properly, all right, we can get started. All right. So here we go. I'm going to maximize this right here. There we go. All right. Let's do this. Let's go ahead and read the problem here. Examine the graphs of the expense function and the revenue function. Oh, by the way, do what we always do too and get out some highlighters. So I'd get out a red pen and some highlighters because I'm going to annotate the graph. So pause the video if you need to do that and take your notes in color so you have a well annotated notebook, okay, or workbook as we call it. All right, the first thing we need to understand is that we already know that the demand function is linear. So let's write down some things that we do know from prior lessons. All right, so get out your red pen here. All right, and let's put down some basic concepts. So from the last section here, a demand function, Q in terms of P here. All right, demand function is linear. Sometimes they give that to you, sometimes they don't. Sometimes they give you a set of data and you have to use linear regression to get that. Therefore, it is linear. Okay, it's a line. All right, and the demand function is linear, so is the expense function. Okay, so we are going to get the expense function here too, is use that as well. So the first two functions are linear. Okay, when I say linear, you got to be thinking line, right? Lines. So when you're looking at the graph right here, the one that's aligned, that's your expense function. It says in the number 1 here, examine the graphs of the expense function. All right, and that is the linear function. So let's go ahead and label right here. So let's color code a graph here. Okay, not that you have to, but this line right here. All right, well, let's just annotate it this way. Okay, this line is the expense function. It's early in the morning. I got to get my groove on. All right, so the expense function here is the linear function, and this quadratic function, which we call parabola in mathematics, is called the revenue function. Okay, and it's second degree or quadratic. Okay, so this revenue function, that's second degree. All right, second degree, and we call those quadratic functions. So let me put it over here. So the revenue function, and we're going to be dealing with this in lesson 5 and lesson 6 quite heavily. All right, so everything we do in this lesson here 5, we're going to get even deeper into the discussion here on revenue functions and actually calculate it, graph it, determine the maximum, minimums, the whole bit. But it's a second degree quadratic, so it's quadratic. You guys started learning about quadratics in Algebra 1 a couple years ago. So it's a quadratic function, and that means it's second degree. And quadratic functions look like y is equal to ax squared plus bx plus c. All right, they're not linear, they're quadratic, as you're going to find out. So this parabola right here, all right, let's go ahead and note it. This downward facing parabola is what's called the revenue function. Okay, so we have two functions on the graph. The horizontal axis is in terms of price, so these are prices in dollars. All right, so it's the price of an item or a widget, okay? And then our vertical axis is in dollars, okay? Dollars here, because we're talking about revenue. All right, when we bring revenue into the company here, we're talking about income coming into the company. It's always in terms of dollars. So we got price of the widget or the item on the horizontal axis, and we got dollars on the vertical axis here, and we should be able to analyze the two functions and what's going on. All right, so the first thing in part A, what they want to talk about is like they're asking you what is the price at which the maximum revenue is attained. All right, so let's analyze that. What is the price? Okay, so there always is a price at which the public. Well, actually, let me back up. When no matter what object you're talking about, okay, whatever's being produced and sold, okay. As the price increases, and let's take a look at the function here. As the price increases, going from left to right, okay, so it increases from left to right. The revenue coming into the company here is going to increase. So as they increase the price, they're going to get more income. But there's going to be a point, all right, as you're going up the graph here, okay, on the parabola, there's going to be a point at which the price becomes too high and the public's not going to handle it, and they're not going to like it, and they're going to be end up buying less of it. And when they buy less of the product, whatever the product is, all right, the company's going to reach a maximum revenue or income coming in, and then it's going to start to decline. And that point that we need to find happens to be right at the top of the curve, which we call the maximum. Okay, so this is called a max. Every downward-facing parabola has a max. Every upward-facing parabola has a minimum. But in case of the revenue function, these functions are always quadratic, number one, and they're always downward-facing, number two, because there's always a maximum of which maximum revenue which occurs, and it occurs at a certain price. And so what you do is you take a look at the top here, which we call the vertex of the parabola. So the max is always at the vertex of the parabola. So we're going to be using all those Algebra 1, Algebra 2 techniques that you learned, okay, talking about the vertex here. And you're going to estimate it first. So this first problem here is just about analyzing here, just identifying the maximum, which always occurs at what's called the vertex of the parabola. And this occurs at a price that it's a little bit above 160. All right, and the graph is not really... the interval between 160 and 240 here is about 80, right? 160 and 240 is 80, so right about here is about the 200 mark. So when you estimate this, it's a little bit about 160, we can say about 170. And then at that price of 170 here, let's say the price is approximately equal to $170. Right, we get a maximum revenue, and that maximum revenue can be found by looking at the y-axis here. So you move left, okay, and you go to the vertical axis here, and the interval here on the axis. Let's talk about that for a moment. We got 2 units to get to 15,000. So 15,000 divided by 2 is 7,500. So each line on the grid line going up is 7,500. And then if you add 7,500 to 15,000, you get 22,500. So up here, 22,500. And if we want to estimate the income coming in, the revenue, okay, revenue, income, same thing. Income. It's kind of hard to read, so let me write that again. Okay, so the income coming in is called the revenue. The maximum revenue occurs when the price is about 170, and that maximum revenue we estimate, I don't know, it's got to be above 15,000. So there's 7,500 between these grid lines. We're about a third up, and that's about 2,500 more. So I'm going to estimate this this amount right here about 17,000, 18,000, something like that. So 17,500. This is an estimate. Okay, this is an approximation. So it says estimate, right? So this maximum revenue is approximately equal to 17,500. All right, I don't know exactly what it is in this situation because the scale is too big. So we're just asking for what's called an estimate. All right, just look at the graph and give me an estimate. All right, part C and D are important too. Part C asks you to estimate the leftmost break-even point. Okay, so what in the world is a break-even point? That's one of the main concepts of the lesson. So we better go off to this side. Okay, and let's talk about the break-even point. Put this big bold in red. Break-even point. All right, and that occurs when revenue meets expense or equals expense. So when the revenue, all right, equals your expenses, you break even. You're not making money, you're not losing money, all right? And so when does that happen? It's when the curves intersect. So you're looking for the intersection point. Okay, so when revenue equals expense, that means is that you look, all right, for the intersection point of the two curves. Intersection point of the two functions. Okay, so let's do that. Okay, that's how you do it graphically. All right, so our break-even point is when revenue is exactly equal to expense. The amount of money coming in, all right, this is coming into the company equals the amount of money going out, because to run a company, there's a lot of expenses. All right, and when that happens, you're not losing money, you're not making money, you're not profiting. All right, because they're actually equal. All right, and so when you start making more money than you're expending or spending, then you start profiting. Okay, so after the break-even point, you make money. Before the break-even point, you're most likely losing money. Now, in this case, we have two break-even points. So let's go back to the graph and let's take a look at this. Okay, so here, let's highlight them. All right, we have two break-even points, one at A and then one at B. Okay, A and B are break-even points. Now, it asks for the leftmost one. Okay, and the leftmost one is at A, and it asks you to estimate it. So what is that? So what you do is you go down, all right, and you take a look at the price, and you estimate that. Okay, and then let me see. So halfway between these things here is there's $80 in between each of the grid lines, and so it's almost halfway. Half of 80 is 40, right? So 40 plus 80 is about 120. That's an estimate now, okay? So you have to get close to that. All right, so if you set the price to $120, what is the money or revenue coming in? Okay, well, to answer that question, you have to look left. So you go left here on the curve, all right, and it's a little bit above 15,000, so maybe 16,000 or so. So that's the income. So $16,000 is coming into the company. All right, so the first value, all right, the first value is price. The second value is income, okay, or what we say, revenue. So you have to understand that the first value in the order pair here, if we're looking on the graph, represents price because that's an X value on the graph. Price is on the horizontal, and then on the vertical, of course, is the money coming in. All right, the rightmost break-even point, well, guess what? That has to be at B, all right? So B, so what happens there? So you go down, and then you go left, all right? And you look on the graph, all right? So I estimate the price would be a little bit below 320, all right? So maybe 300, all right? And then over here, if you go left here, it's about halfway between 0 and 7,500, okay? So half of 7,000 is 3,500. Half of 500 is 250. So maybe 3,750. But it's a little bit lower than half. So maybe 3,500. Maybe I'm just estimating. All right. So I'm going to say that the price is approximately equal to $300, and then the income coming in is approximately equal to $3,500. And again, these are only estimates. If we wanted to be more accurate, of course, you would have to be given the functions, go to Desmos, or do some calculation. All right. So the first value represents the price. The second value represents the income coming into the company. All right. And so this first problem here, guys, just make sure that you understand how to read a graph. All right. And make sure that you understand that the expense function is the linear function, the line, and then all revenue functions are parabolic. Okay, we'll call these parabolas. Okay, parabola, or we say parabolic. Okay, because they're parabola-like, and you say parabolic when that happens. Okay, so the revenue functions are second-degree quadratic functions, which we call parabolas. They're always downward facing. All right, because there's always a maximum revenue that occurs in a company, as the price increases. All right, and then you can go from there. All right, let's get into number two. Number two, it says identify the maximum point by using the axis symmetry. We're going to actually do this both two different ways. We're going to do it by hand using what we know of quadratics, And then we're going to use Desmos here because of the technology and it's easy to use. So I'm going to do it by hand first, and then I'll back everything I say with Desmos. All right, so let's get started. So our goal is to find the maximum point here, and any maximum occurs at the vertex. So the first thing we need to remember is that it occurs at the vertex. And you have to remember from Algebra 1 how to find the vertex. Okay, so in red, let's put it in the margin here. You got to find the vertex. And you do that by understanding that x is always equal to negative b divided by 2a. All right, and this is the first coordinate of the vertex. All right, so the vertex v is always located at negative b divided by 2a, comma, and then f of that value. Okay, so f of that value, negative b over 2a. And if you don't know what that means, it means you just take your x coordinate here and you substitute it into your function, all right, and you evaluate it, and you get your y value. All right, so this is just the y value and it represents your income. All right, so what you also have to understand is, go off to the side. I'm gonna take this over here so we have a little bit more room. All right, and I'm going to say something here. So quadratic form. Okay, now in Algebra 1, you wrote it like this. Y is equal to ax squared plus bx plus c. All right. Now our quadratic over here looks like r, all right, is equal to negative 20, negative 2,000, excuse me. Okay, negative 2,000 p squared, because, you know, instead of x, we have p for price, right? And then plus over here, 44,000 p. Okay, so let's focus in on this. I'm going to do all my work here. This is part A now. On the side, that's why I always say take your spiral out, guys, and do your work in your spiral, because there's a lot of work to do and you can't fit it all in this little workbook. Okay, now understand something here. A happens to be negative 2,000, okay? This is straight from Algebra 1, okay? The linear coefficient happens to be 4,400. All right, so I'm going to write down my values here. So I know just by looking at this that A is 2,000. I know that the B value, the linear coefficient, is 4,400. All right, so when I'm trying to find the vertex, all right, I always start off with finding the x value of the vertex first, and it's always found by taking negative b divided by 2 times a, which for us, b is 4,400. So I take negative 4,400 here and divide it by 2 times a, which is negative 2,000. So I simply substitute my values in, and I get negative 4,400, all right, divided by negative 4,000. Now a negative divided by a negative is a positive, okay? So we got a positive here, but positive what? All right, so here, let's just do ourselves a favor, and if you can't do this in your head, well, let me show you. All right, you cancel out the leading zeros, okay? That's divided by 100. And then, let me see, 44 divided by, oh, you know what? I made a mistake somewhere. Where's my mistake? What happened? Let me look. Oh, I didn't write it down correctly. B is 44,000, not 4,400. Oh, that's why. Okay, I knew I made a mistake somewhere here. Okay, it's 44,000. I missed a zero, guys. Look right here. Look very closely. It's not 4,400. It's 44,000. That's what happens when you run a video at 5 o'clock in the morning or 6 o'clock in the morning. All right, so let me put another zero in there. So let me redo this number here. Okay, so let me start over here just to make sure you got it correct. This is 44,000. So negative 44,000, all right, divided by 2 times negative 2,000, which is negative 4,000. So negative 4,000. Okay, so now it's clear. Okay, so now notice they both end in 3 zeros. So you cancel out 3 zeros up top, 3 zeros down below. That's simply multiplying by, dividing by 1,000. All right, and then you simplify. Negative 44 divided by negative 4 is 11. All right, so positive 11. So x is 11. So x equals 11. And then what you do is you substitute this back into the function here, and you go for it. So r, the revenue, okay, not y, but r, all right, is negative 2,000, all right, times 11 squared, oops, all right, times 11 squared plus 44,000, all right, times 11. All right, you substitute it in into the function. I say x, it really is actually p. Okay, so p is 11. X and p are the same thing, right? Because we're talking about price here, so this is actually the price. All right, so then we figure this out. So let's go to our famous calculator here that we use in this class, and let's just type it in. All right, so we're going to take, you just type it in directly as you see it, guys. It's so simple. So negative 2,000, all right, times, all right, times 11 squared, all right, plus, again, you just type it in directly. Desmos is so user-friendly, it's not even funny. So as long as you can type and read, you can do this, okay? And so notice that you get 242,000. So here we go. So R is equal to $242,000 right there. That's called the max revenue. So make sure you understand what you are doing here, guys. All right, we're trying to find where the max occurs, and occurs if the price is set at $11. Okay, so let's go back to the problem here. So the maximum occurs at, okay, a price of $11, and the maximum revenue is big, all right, $242,000. Okay, price and then revenue. And make sure you understand which is which, okay? I'm going to be asking you guys to interpret all the time. All right, the price is $11, the maximum revenue is the y coordinate, and that, in this case, represents $242,000. All right? All right, now, the next one here, all right, let's take a look at number 2b. Right here says R, the revenue, is equal to negative 125, all right, p squared plus 3200p. All right, let's work on this one now. Gotta work on my handwriting right now. I gotta get a new pen. So A and B, and again, you always start off with your x-coordinate, which happens to be p in this case. All right, so negative b divided by 2a. So instead of x, we should write p, because we're dealing with price here. Instead of x coordinates, we got p coordinates. All right, so negative, all right, negative b, which is 3200, divided by 2 times a is negative 125, okay? So we got negative 3200 up top, and then 2 times 125 is 250, so divided by negative 250. Once again, a negative divided by a negative is a positive, all right? All right, okay, and so what is the p-value? Okay, I'm gonna switch to p because we're not dealing with x and y anymore, all right? And then we simply divide, right? So let's do that, all right? So you take negative 3200, well, you can ignore the negative signs because the negative divided by negative is positive. So you take 3,200 divided by 250, right? We already know it's a positive number, and you get 12.8. All right, so good. So you get 12.8. So the price is 12.8. And then I got to take this and I got to substitute it in. All right, so what's the revenue now? So negative 125 times the 12.8 squared plus 3,200 times 12.8. Well, R stands for revenue, right? So what is that revenue? So you type exactly what you see. So negative 125 times 12.8 squared, all right, plus, all right, 3,200 times 12.8. All right. And then you get 20,480. So the revenue is $20,480 if the price is set at $12.80, okay? And so when you want to write that as an ordered pair, let me see, let me double check that. Looks like, yeah, it looks like I got that correct, okay? All right. Just double checking things here. Yep. Okay. So our let's go back to the lesson here, and we just want to bring results over here, so it makes sense. All right. So our maximum occurs if the price is set at $12.80. Then the revenue occurs or we obtain, excuse me, a revenue of $20,480. Okay. All right. So it's kind of nice to have your spiral handy, but you can't fit all your work, my friends, in this teeny little workbook. Okay, and make sure that you scan all your work and from your spiral and include that when you submit it in Canvas. So submit, okay, all work in spiral, all right, with the workbook. If you don't do that, guys, I'm not going to give you full credit, because you can't just look at these problems and get an answer. I mean, just look at it right here, guys. There's a lot of work to be done. All right, now before we get into number 3 here, I do want to show you how to do this in Desmos. All right, so we're going to take a break and validate. All right, the second one. I'm going to do the second one here. So what we're going to do is we're going to type this in. And instead of R and P, I'm going to type in Y and X just as a regular, normal looking function. Okay, so I'm going to type in Y is equal to negative 125 X squared plus 3200X, which represents our function. And watch what happens. So Y equals, all right, negative 125, all right, X squared. Just type in exactly what you see, all right, plus 3200X. Okay, there's your revenue function in respect to, or using the variables Y and X. So Y represents your revenue, X represents your price. Okay, now I'm going to expand it here and take a look at this. All right, so notice we don't see a parabola here, and it's because our axes are not set correctly. All right, because these are big numbers right here. So I'm going to adjust a little bit manually first, and then if you have a touch screen, well, then you can use your fingers to zoom in and out, but I'm going to do it manually. So I'm going to set the price between 0 and 20 to see if that's sufficient. So 0 here and 20 for the price. And then that may not be big enough. Actually, let me see, our maximum occurred, what value? At 1280. So yeah, that might be good enough. Okay, and so notice our maximum revenue was huge. So let me go back here. So 0 here, 0 to 20. And just put a step of 1 with that. So we're counting by ones, or $1 increments on the price. And then here, your revenue, let's start at 0, because you can't have negative revenue. And let's go up to, I don't know, 30,000 maybe. See if that's enough, with a step of maybe 500. Okay? And let's see if we can see our parabola. Okay? Not entirely. So what we can do is, I'm adjusting it on the screen right now. Notice that it hits the x-axis at 0 and somewhere over here at between 25 and 26. So you're going to have to adjust your x max, accordingly. I went from 0 to 20, which was not sufficient, so I need to go maybe 0 to 30. So if you go back up here and go from 0 and use 30, or your x max, then you'll be able to see the entire parabola. Okay, now where does the max occur? Well, if you take a look on the function here, just click on your parabola here and move left to right. You'll notice that the revenue is increasing until you hit the max, which is at the top, and then it starts to decrease, because when the price gets too high, public doesn't like that. They stop buying as much, and then the revenue is going to go down over time as the price increases. All right, so what's cool about Desmos is that all you do is click at the top. You see a little point up there. All right, click on it, and it gives you the max. And guess what? That's the same values as we came up with earlier. All right, so what's cool about this is that Desmos can verify your algebraic work. And we came up with a price of $12.80 and a max revenue at $20,480. And sure enough, Desmos agrees. All right, so when you do this with Desmos here, just go ahead and enter the function. And then it can verify your algebraic work. So I'm just going to bring that in just to verify. Okay, so let me import this in just for funsies right here. So we got our function. So going back to our previous work right here, notice that what we did algebraically here matches. So if I zoom in here a little bit, right here, annotate a little bit, the max occurs right here. Notice the coordinates are the same. So those are the coordinates. So we've got price here, and then revenue second, okay? So $12.80 right here, that represents your price, okay? And then we've got a revenue here at $20,480. That represents the income, all right, coming into the company. All right, and it always occurs at what's called the vertex of the parabola. All right, and the max always occurs at the vertex. So let's write that down again. Max always occurs, all right, at the vertex of the parabola. All right, major concept right there, guys. All right, so we can do it by hand and we could use Desmos. Oh yeah. All right. Now there are a few more problems to handle, so I'm going to do number 3 as well, and then of course, you got to do something on your own, and number 4 sounds good. Okay, so let's go a little bit further in the lesson here, and let's go through number 3. All right, Jeff's company here manufactures custom t-shirts. All right, each shirt costs $2 to manufacture and print. Okay, there's your unit cost right there. So let's note that. So already I know the unit cost. Let's write these down in the notes, okay, in the margin. So the unit cost is right up here, $2 per shirt. All right, $2 per shirt. So I know the unit cost. The fixed cost of the product line is $2,000. All right, so we know the fixed. All right, it's $2,000. We know the unit cost. So right here, and then the second one right here, these two things that we are outlining here are super important in solving the problem. So we know the fixed costs are $2,000. We know the unit cost. Guess what? We can write the expense function. Check that out. Now they give you the demand function right here. So the quantity demanded is in terms of the price. It says it's equal to negative 1200p plus 7800, where p is the price of the shirt. Okay, that's called the demand function. All right, so we also know that, and that's a key thing that we were talking about in our previous lesson here, the demand function. And it has a negative slope because as the price increases, okay, over time, the quantity demanded by the public is going to go down, and that refers to a negative slope. So these demand functions always have negative slopes, and they are always linear, okay, as I was talking about earlier. All right, so you have to really understand what you're doing in order to solve the problem. So always outline it first. All right, make sure you understand what's going on, and then you can go for it. All right, so the first thing they want you to do is write the expense function in terms of Q. Okay, so let's do that. So the expense function in terms of Q. So the expense function in general is equal to your variable expenses plus your fixed costs. So variable plus fixed. And this comes from a couple lessons previous. Okay, so variable expenses plus fixed. Well, the variable expenses comes from the unit cost. All right, so each shirt is that is produced costs $2 to make. So we need to take our unit cost times the quantity, okay, because we were talking about earlier in a previous lesson that the variable expenses is always equal to our unit cost, all right, times quantity, Q. All right, so for us, for this one right here, it's 2 times Q, all right, plus the fixed cost of 2,000. So I have an expense function now. So the total expenses in this situation is 2 times Q, where Q is quantity here, all right, plus 2,000 more. All right, that's called the expense function. Now notice it's in terms of Q, all right, it's in terms of the demand Q. What we need the expense function in terms of price. All right, and we talked about that in a previous section where we take the price, our demand function, and we substitute it into our expense function. So if you remember that, that's what we did. All right, so I know up here in the top here that Q is equal to negative 1200p plus 7800. So I'm going to take that and I'm going to substitute it into our expense function. I'm going to rewrite the expense function in terms of the price. So I need an expense function in terms of P. All right, so here we go. So I'm going to rewrite the function over here. I've got E is equal to 2 times Q, all right, plus 2000. All right, now Q, I know, is up here. I know Q, let me put it up top. Q is equal to, all right, negative 1200, all right, P plus 7800. I don't know if you heard that, but that's my donkey calling me. That's so funny. All right, so what I need to do right now is I need to take this right here, this quantity right here, and I need to substitute it into the function so I get the expenses in terms of the price. So here we go. Let's do it. So I've got the expenses now is equal to 2 times whatever Q is. All right, plus 2000 more. Simple substitution. So I bring that in. I get a Q is negative 1200 here. All right, times P plus 7800. So I substitute that in. I'm going to bring down the constant 2000. I got to distribute through the 2. All right, distribute twice. All right, so I've got the expenses is equal to 2 times negative 1200. That's negative 2400. All right, P plus 2 times 7800. And let me see, 2 times 7,000 is 14,000. 2 times 800 is 1,600. 1,400 and 1,600. Sounds like 15,600. Ooh, is that correct? Let's see. Okay, so let's write that down. So 15,600 plus another 2,000. All right, and we've got to add the like terms. So my final step would be negative 2,400. All right, P plus, let me see, 15,000 plus 2,000 is 17,000. And then I got that 600 laying around. So I've got 17,600. And now I have an expense function in terms of P. All right, because it's E equals negative 2,400 times P, not Q, but times P. So we say in terms of P. All right, so let me write it up here. All right, so now we have an expense function in terms of the price, which is important because I have to graph this thing. All right, and if I'm going to graph it with the demand function, everything has to be in terms of the price. So that's one of the reasons why we had to do that, is because if we're going to graph it on the same graph like we did in number 1, notice that the horizontal axis is in terms of price. Okay, you have to represent your expenses in terms of price as well. So that's why we had to make that step. Very important when you graph multiple functions, same graph, that you have to use the same units or the same quantities, okay, for the independent and the dependent variables. Now it says write the revenue function in terms of the price. So this one's new. Okay, so what we need to do is do this for the first time. So the revenue in general, and again, this comes from our previous lessons, is going to be equal to your quantity times the price at which you're selling these right through here. So it's going to be price times quantity. So in general, the revenue is price times quantity in general. And I'm running out of room, so you know what? I'm going to have to go into our spiral here. So let me do that. Let's go off to the side so you can get a better view. Okay, so revenue. So let me excuse me. So revenue equals price times quantity. There we go. P times Q. All right, so here we have P, all right, P times Q in general, price times quantity. Now we know Q, all right, now the quantity demanded, or your demand function, now needs to be substituted in here. So I'm going to take our demand function, I'm going to write it above here. So look in the main problem here. It says up top here in the main problem that Q, which is your demand, right here, is equal to negative 1,200 times P, all right, plus 7,800 more. This is your demand function. I'm just rewriting it over here on the side so I can see everything all together. Okay, so let's zoom in here and let's take a look at this. So what we want is a revenue function in terms of price only. So what I need to do is I need to take this quantity here and substitute it in for the quantity, or in for Q, right? So let's do that. So revenue, R, is going to be equal to P times Q, but Q is equal to negative 1200 times P plus 7800 more. So you're always going to substitute your demand function into the revenue function. Substitute your demand function into the revenue function. You're going to do this every single time. And when you do this right here, when you do that, you're always going to get a quadratic. And you're always going to get one that faces downward. All right, because revenue functions always have a max, and the only way to have a max is to have a downward facing parabola. All right, now what we need to do is we need to distribute through, right? So you want to distribute, and see what you get. So negative 1200 P times P gives you negative 1200 P squared, because P times P is P squared. And then P times 7800 is simple, it's just 7800 P. And now you have a quadratic, okay, which we call a parabola. Now, if you remember, when A is negative, okay, this is A and this is B. When A is negative, it opens down. So when A is negative, it opens down, and that's important because every revenue function should be doing that, because it always has a max. Okay, so now let's go back and read the problem here, and let's see where we're at. Okay, I always got to go back to where you started. All right, so it says write the revenue function in terms of the price. So I did. So what we're going to do is we're going to take this function here. This is our main one right here. So revenue function, so way over here. All right, and then we're going to graph it using Desmos, and we're going to determine the max. Okay, so this is graph the revenue function. We're going to use Desmos, and then we're going to identify, what price gives you the max. So, so P equals question mark, all right, which would give us, some max value. Max equals question mark. So let's answer these questions here. So let's go to Desmos and let's put it in. All right, so here we go. All right, so getting a little crazy on my technology here. My computer's running a little bit slow. So it's all right, having a little tech glitch. Okay, so now what I want you guys to do is turn off the previous function. Just deselect it. Do not delete your work. Okay, just turn off your colors and hit the save button. Okay, so now let's type in our function here. So instead of R, I'm going to use Y. Instead of X, I'm going to use P. Or excuse me, instead of P, I use X. And so you just pretty much type it in exactly how you see it. So Y is equal to negative 1200 X times X squared, all right, plus 7800P, or 7800X. So now we have a function. So I'm going to zoom in here, or zoom out, and take a look. You might have to adjust your viewing window here. So I have a touch screen, so I'm adjusting my viewing window. If you can't do that because you don't have a touch screen, you go in here and you adjust your X minimum, X maximum, Y minimum, Y max, just like we do in class. All right, that's a skill you got to get good at. And then as you notice right here, if you click on your parabola here, your revenue function, the price or the revenue is going to go up as the price goes up, but there's going to be a point where the price gets too big, and then the revenue coming into the company is going to go down. It's going to decrease because the public's not going to want it because the price is too high, right? So what is that price that maximizes revenue? Well, click at the top of the vertex. All right, and then what you'll see is that we have a maximum revenue occurring if we set the price to $3.25. All right, so let's go ahead and let's bring this in. I'm going to import the graph in here so we can see it a little bit better and see what's going on. My technology is running a little bit slow right now just because I'm producing a video here, which takes a lot of computer power. All right, so what we have here is we have a maximum. If we look at the graph here, so this is your max revenue, okay, and this is your price. So the price occurs at $3.25. Excuse me, the max revenue occurs if the price is set at $3.25, and the max revenue occurs at that price, and so $12,675. All right, so sketch that into your spiral here. Okay, if you're not digital like me, all right, just sketch it. All right, so you know what's going on. So when, at what price does the max occur? Okay, as I just said, all right, at $3.25. At that price, the maximum revenue occurs, and the company will obtain $12,675. All right. And the only thing we need to do is talk about the roots. All right. Use any of these methods learned in the section to determine the roots of the revenue function. Interpret these roots in the context of the problem. Oh my gosh, interpret. I keep talking about that. Okay, so we need to determine the roots, and then we need to interpret. Okay, so the roots of the function is where the parabola meets the x-axis. Okay, so these roots are the x-intercepts. Okay, x-intercepts. All right, and so we have two of them. So first understand that roots graphically are found by looking at the x-intercepts. So we have two of them. So let's look at those. Let's go back to Desmos here. I should have done that first, but that's okay. So you click on the first x-intercept at 0, 0. You click on the next intercept, and that's at 6.5, 0. So let's go back to our graph here and annotate. So here's the first root. Okay, so the first root is at 0, 0. All right. Okay, so and the way you interpret that is that P, it's always P, R. Okay, so if price is set at $0, then the revenue is $0. Okay, there's your interpretation in terms of the context of the problem. And in this one here, the second root, okay, there's another root here, and this one occurs at, let's go back to Desmos here, forgot what it was, 650. Okay. So this one right, halfway between 6 and 7, so it's 6.50. So the second root is at 6.50, 0. So if the price is set at $6.50, all right, revenue will be 0. They won't make any money, guys. All right, no money will be coming in. And that's the context of the problem. All right, so if you set it too low or set it too high, you're not going to have any revenue. Okay, that's the point of the discussion. So there's always a price, a magical number here, where the maximum revenue occurs, and it always occurs at the vertex. So that point right there is going to be the special point to find in any business problem. And then the roots are just two different places where the company is not making any money. Okay, and that right there is number 3. All right, now your job is to handle number 4, right? You got to do something on your own. This, my friends, is very similar to number 3. All right, so use everything I talked about in number 3 to help you in it. So this is homework here. Do a good job on this one here. Use Desmos first, okay? Use Desmos when appropriate, okay? So, and then also check answers with publisher, because I published the answers. Okay, so check answers with publisher, and that's in Canvas. Obviously, you guys know where they are. Okay, and then I will see you in my next lesson here in section 6. We're going to apply everything that we just learned and then some. All right, here, and then I'll get into it. So that's going to be on next week here, and section 9.6 is the most important section because section 6 puts it all together. So make sure you're here with me. All right, this is Mr. Aynesworth in Great Oak High School. I'll see you guys later in my next lesson. Bye-bye.